to introduce Yves Bergquist from Entertainment Technology Center at USC. So Yves is a data scientist and the director of the Data and Analytical Project at USC's Entertainment Technology Center. Well, he helps the Hollywood studio deploy machine learning and AI throughout their operations. He's also the CEO of, what's the company name?
Corto and Novamente.
Yeah, which is building the first AI-driven knowledge store for enterprise. So he will be presenting a talk titled "The AI Takeover in Hollywood." Please join me in welcoming you.
Talks in the dark, I love it. Thank you. Thanks for having me. I have the pleasure of being the founder and director of the Data and Analytics Project, the Entertainment Technology Center. ETC is a very, very, very cool place. It is a think tank where the entertainment industry talks about technology. It was created by George Lucas in the 1990s. The cool thing about it is that we're at USC, we're part of the School of Cinematic Arts, and so we have a foot in academia, but we're also very, very tightly linked to industry. So I personally report to all the 6 CTOs of all the studios. And as you can imagine, right, I have the freedom of academia of having crazy ideas and building crazy things and failing and things like that, but also have the opportunity to deploy whatever successful systems I build across an entire industry, which is a great opportunity, and I'm very happy to do it. We have the Data and Analytics Project really seeks to help the studios deploy advanced data and analytics solutions throughout their operations. That includes machine learning and AI. In the field of audience intelligence, to help creative marketing, production, which I'll talk about Project Snowflake, and operations, looking at how to manage all of the knowledge that's produced internally by the studios in hundreds of different formats and taxonomies, and of course content security. Quickly on Project Snowflake, it's sponsored by Google. It's a very, very cool project that we're building. It is the world's largest film database. And as part of this film database, we have a database of film looks. And the whole notion is to help producers, especially independent producers, understand. So if they have sort of a lookbook about what kind of look they want to have their film, they can upload some stills, and the system will immediately recognize what kind of equipment they need, what kind of talent they need, what budget they need, and even do sort of an analysis around films of this genre in this category of film looks tend to make this much money in these markets. So it's a very, very comprehensive database. It's very cool. I'm also very privileged to be working with some of the best AI engineers in the world as part of Novamente. It was founded in 2001. We have about 50 employees, 71% with PhDs. We're based in LA, and the second team is in Hong Kong. The 2 people that I'm doing this with are Ben Kurtzel, who's introduced the concept of HEI, probably one of the top 5 AI engineers in the world, and Dr. John Gonzaga, who joined a little startup called eHarmony and created the entire behavioral data platform, and then left that and joined another startup called Netflix and created their entire content algorithm platform. So he's, in terms of data science, just a beast. So we have extreme expertise in AGI. We'll talk about narrow AI versus AGI in a minute, but so this is the only blueprint towards human-level machine intelligence. We talk about Elon Musk and OpenAI. There's no other mathematical and engineering blueprint to human-level AI in this, and as we'll see, it's a radically different architecture than just all neural nets all the time that other organizations have chosen. We built some very, very high-end AI platforms in the media and entertainment industry. We really focus around surfacing, mining unstructured data like text to surface narrative structures and correlate them against any kind of dependent variable in ROI to understand if everything is stories, what kind of stories generate the most returns. And it's something that's been very, very popular in the advertising, marketing, media, and entertainment sectors. We also do a lot of national security work. We've built a hedge fund that doesn't have any humans in it, that trades entirely by itself. And we have built the AI application behind Sophia, who some of you might have seen on Charlie Rose or Fallon. It's also sort of the first truly AGI application. So you'll hear a lot, this is a bit of my pet peeve. You hear a lot of people talk about AI when all they do is really machine learning. And it's cool, machine learning is really hard. There's nothing wrong with machine learning, but machine learning is not AI, right? So, and there's a lot of confusion around the two terms, and so I want to clarify this a little bit from our standpoint. So if you think about your own intelligence, the capability to learn is definitely a foundation of it, but it's definitely not it. So a few things differentiate machine learning applications from true AI applications. And in my view, there's really three elements. One, there's a dimension of knowledge representation. Right? So you have to have data in different formats and taxonomies, and there has to be a knowledge representation application as part of an AI application to turn that data into knowledge, right? To represent that data as knowledge. Number two, that application to be an AI application has to take some kind of action. If you're running models and training models, you're doing machine learning, you're not doing AI. If you're building an application that takes action, then you're probably doing AI. And also that action has to have some level of recurrence. In other words, the application has to measure the performance results of that action and layer the performance results into models so that it learns over time. So a self-driving car is definitely an AI application, right? So it has a dimension of knowledge representation. It has definitely a learning component. It takes action in the real world and it measures the performance results of these actions and layers those performance results in the models. And so that's really important because I think just calling everything AI is just offensive because real AI is very, very difficult. So narrow AI versus AGI, maybe some of you know this, but so narrow AI is an AI application that operates at human level or above human level in one domain. So you can't take a self-driving car application and make it drive motorcycles or trucks. You can't, AlphaGo was trained on a 19 by 19 Go board. If you had it playing on this Go board, you would have to completely retrain the application. So that's narrow AI. Artificial general intelligence, and if you look at this as kind of the cognitive architecture that we work with at Domomente. Some of you may be familiar with the OpenCog project, with the people behind the OpenCog project, which is open source AGI. But an AGI so it's really going from machine learning to machine understanding. An AGI application generalizes across domains, right? So it's one AI framework that can drive a car, trade stocks, learn a language, just like our own brain is able to do all these things, which is narrow AI, which is just a one-trick pony. Can solve real problems, but not the same thing. So we have a philosophy of AI that is really built on a whole cognitive architecture. We use neural nets, but we use many other algorithms as part of the OpenCog and Novamente systems. It's really sort of what's called an integrated neural symbolic approach, where we have neural nets, but we also have evolutionary learning and probabilistic logic. I'm happy to take this offline if you're interested in diving into the system. It's at opencog.org and it's open source, so you can all play with it. I'm going to pass on this. So in terms of entertainment, right, this is a really interesting industry with a very unique set of challenges. There's a lot more complexity in making movies and selling movies as products than there is in making cars and selling them. Now, if you think about your customer as a car company, your customer isn't a car expert. Some of them are, not all of them are. It's been reported that in our lifetime we buy anywhere between 9 and 12 cars. How many movies do we watch in our lifetime? thousands and thousands of movies. So the entertainment industry is facing itself to sell its product to customers that are absolute experts in the product, right? And that's tough. And there's also a real cognitive dimension in a film that there really isn't in other types of products. That really creates a lot of complexity. The fact that we're all movie experts here is a considerable challenge for the studios because they know that they need to innovate in telling stories in film. They just don't know where. Somewhere you need to innovate. You can't innovate with everything. So if you look at the success of Deadpool, for example, which was sort of a breakthrough superhero take on the superhero genre, Deadpool had a perfect mix of sticking to the superhero canons and innovating a lot, right? So it's really, you can't do either or, and you can do both. At ETC, we're doing a lot of research on the mathematical representation of why we think certain things are interesting, which I'll talk about. Another challenge is that we have, actually, the amount of time that we have to entertain ourselves is going down, and the supply of content and the number of options that we have to entertain ourselves is going up exponentially. And so that's a huge challenge. When that happens, there's really a function of utility that goes in that is very, very cognitive in people's minds, where every single piece of entertainment decision is dominated by de-risking. Is this 5 minutes that I'm putting into this piece of entertainment? Am I going to have the maximum experience out of it? Am I going to have the maximum experience out of going to the movies and parking and just investing all this time into watching a movie? And that really explains why we have increasingly more pre-awareness movies and superhero movies and sequels and things like that, is because if you look at this is the investment versus the amount of available information. If you're going to the movies and you're investing all this time to watch an independent movie that you don't really have a notion of, then it's definitely the risk is really high. If you're going to see Captain America in IMAX, there's that somehow or another you're going to have a fairly good time. Maybe it's not going to be the movie, your favorite movie, but it's going to be very entertaining. So that's that de-risking, that cognitive de-risking, is really something that we really work on at ETC. We use decision sciences. And so where's Hollywood? So So contrary to what you may have heard, Hollywood's actually doing extremely aggressive with the data analytics of AI and machine learning. That understanding isn't sort of uniformly across studios. Some studios are way more advanced than others, but Hollywood is somewhere around here, and there's a lot of variance in how much effort is being put behind data analytics in the studios. But everyone's really getting very, very aggressive about it. So we at ETC have a very unique approach to this. We really look at everything behaviorally and cognitively, right? Because A, it's really fundamental to the entertainment experience, and B, it really hasn't really been done before. Nobody's really been looking at entertainment at a very cognitive level, neuroscience level, so we do a lot of work around that. And we try to really think behaviorally about audience intelligence, and really the big question is why? Why do people go see this movie? That seems like a simple question. It's really hard. It's a really hard question. It's not really a question that a lot of people in Hollywood can answer on a very granular basis. Like, why do we choose to go see a movie? Why do we like this movie? Why did people like Wonder Woman, for example? Right? What's the reason? So this is something we put a lot of effort in, and something that we found. There's definitely an about gorilla in the room when you're thinking about entertainment and data and things like that, and trying to measure why people go see the movie. It's stories, and there really hasn't been an enormous amount of research behind that. And so we really have done a lot of work in that field. And what we found is actually Silicon Valley and Hollywood are in the same business as making algorithms. A story is is an algorithm. A story is a set of steps to solve a problem. Does that sound familiar? That is exactly the definition of algorithm. Right? So there is an algorithmic structure to storytelling in film that is really, really staggering, that you can measure, that we have measured. And that is extremely similar to how software engineers construct an algorithm, a synthetic algorithm. One of the things that we've done to get us on this path of really understanding the cognitive relationship between audiences and film is to think about, well, why do certain things seem interesting to us and more interesting to us than others? Why do certain stories and brands and products and people? And we used Jürgen Schmidhuber's theory of interestingness to look at, well, can we define mathematically what interestingness is? And so we've really done a lot of work around that. And we've defined it as such. Your brain has different ways of processing data. If you're in a very, very familiar environment, your brain doesn't need as much data to represent that environment. So the compression rate is really high. If you're in a very new environment, your brain needs as much data as possible to represent that environment. The compression rate is really low. If the compression rate is too high, this is what we call boredom. Right? This is why relationships fail. This is why things are not as exciting, because the compression rate is too high. Your brain constantly needs new training data. If the compression rate is too low, it's overwhelming. It's not interesting to tune out. There is a perfect middle where there's a perfect superposition of elements in everything, whether it's a political idea or a person or a film, that are familiar to us, and elements that are unfamiliar to us. So going back to my Deadpool example, Deadpool had a perfect superposition of elements of the superhero genre that were expected and familiar to people, that people really were expected to see, were there to see. And a perfect amount of high compression rate and a perfect amount of low compression rate elements of innovation in that film in parallel to that. And so we've built a few systems that mine social media conversations, for example, to really score the interestingness of anything, of a person, a brand, a product, based on the ratio of elements in the conversation about that person, about that brand, about that film that are stable, and elements that are rising and new. And this is pretty cool. We've applied that in addition to other techniques to, we've done extensive research around the narrative structure of stories and which narrative structures correlated to higher box office returns. Again, to try to really nail down that sort of cognitive relationship and really look at what kind of narrative structures resonate more with people. And so we've taken 300 movies, we've tagged them to dozens of variables, looking at, what is the overall story about, what is the main character about, what is the influence character about, what is the relationship between these two characters about. We use a taxonomy called dramatica, and so at every point in the movie, we're tagging this as like, well, this point is about understanding, this point is about becoming, this is and we've found some really, really cool things with it. So this is how it looks like. So the study's going to come out in about a month. This is what is the overall story about in Signpost 1, which is the beginning of the movie, and how does that correlate to box office returns? And if you see this is really interesting, because things like becoming and doing tend to overperform at the box office at the very beginning of the movie. But if you look at these purple bars, conscious, memory, pre-conscious, these are what we call the internal states. So this is telling us something that we already knew, but this is really cool because the data is telling it to us. Which is that when the action in a movie is within a character, which is very popular in theater, it does very poorly in film. Film is a visual medium, right? So the more visual character motivations and story mechanics are, the more popular the movie is going to be. And there's just a million other findings that we have, and I don't have enough time to cover it, but you'll probably, the study will be available on the ETC website. We've looked at also mapping character arcs and story arcs using natural language processing and across sort of dozens of psychographic dimensions, and then again sort of correlating that versus box office returns or Rotten Tomato scores to look at, hey, what's the stuff that's really, are there any patterns in the kind of stories and the kind of characters that tend to generate better returns at the box office. We've tagged thousands of characters to their MBTI profiles, and then we sort of looked at which one of these characters had generated, one of these MBTI types had generated the most box office returns. Done a lot of work, this is kind of cool, we've done a lot of work around influence, right? The way influence has been defined in tech has been just horribly lazy. So we're really trying to do it a little bit better. And we're trying to do it in a way that helps the studios understand who are the people who are the most influential in getting other people to go see a movie, right? And so what we've done, we've looked at the election on Reddit. We've taken millions of Reddit posts about Clinton and Trump, and we looked at where do the Trump fans talk about Trump? Where do the Clinton fans talk about Clinton? If you look at this is really, really interesting. The Clinton supporters mostly talk to themselves about Hillary Clinton. Now the Trump supporters, on the other hand, were going really, really far outside of the Trump subreddit to talk about Trump, and obviously probably troll a bunch of people. So this is something that we really, but it matters, right? If your fans are only talking to themselves, they're really useless. Now if they're going outside of your fandom to really convince other people to, yeah, go see this movie, it's really awesome. They have more value, and we're able to tell the studios, well, these are the fans that are the most influenceable, which we call the turnables, and these are the fans that are the most passionate and the most influential, and what is that influence on? So we worked with a partner company in the Bay Area called Shinobi on this, and those results are also really amazing, and they're going to be published very soon. We've applied a lot of this research to building a tool which we call Contender, which mines social media data for, again, narrative structures. Again, well, if you're L'Oreal, right? If you're Ralph Lauren, what happens when the story around your brand is in a specific domain? Do your sales go up? If your story, the story about your brand is more sexualized in the eros domain, do your sales go up, or do they go down? If your story is more in the ethical domain, do your sales go up, or do they go down? So we have we basically measure quantitatively a lot of qualitative attributes in the conversation, and we correlate them to any kind of third-party ROI variable. So the crown jewel for where all of this is being put is called Corto. We're spinning off our first product out of Novamente. It's called Corto. It's the world's very first entirely AI database. It is a semantic knowledge store based on weight-laden hypergraphs that is able to semantically represent extremely complex data across hundreds of formats and taxonomies. And I'm going to show you, so this is what it is, right? We have a Corto DB, which is a knowledge representation application. Then we have AI tools around it. Now once all of that data is represented really neatly in a semantic container, there's a lot of really, really cool AI machine learning stuff you can do with it. And then it's all outputted in a natural language interface, so you can literally query your data in natural language. I'll show you how it looks like. It looks like this. So studios have a lot of data in many, many formats. I mean, but not just studios. Like GE spends $1 billion analyzing their own data. Pharmaceutical companies have to hire hundreds of data scientists to clean the data and normalize the data. So studios have that problem on steroids. So what you do is you upload all the data into Corto, and then it's just going to across formats, and it's going to process it and represent it semantically. So we have an event detection application that is able to detect events and videos, social media data, P&L data, and then it's all output in a natural language interface. Across hundreds of different formats and taxonomies. So it's also a really exploratory tool. It's analyzing the data whether or not you're asking questions. Moses is one of our probabilistic learning applications. Yeah, the problem-solving skills of the main character are really material to which gender this character appeals to. We find that. So characters that have a very linear problem-solving skills tend to be more popular with males, and characters that have the more holistic problem-solving skills tend to be popular with females. And those can be, so linear problem solvers can be female characters, and holistic problem solvers can be male characters. So Neo in the Matrix is a holistic problem solver, very popular with females. In fact, Keanu Reeves generally plays these roles of holistic problem solving. Interestingly, Wonder Woman has both problem solving skills. Right? She has linear, she beats a bunch of people up, and she's also very holistic in her thinking. So that's it for now. I hope we have some time for Q&A. Thank you very much. Yes. I'm guessing you can give me your email address. I can send them to you. Yeah.
Have you looked at any cultural differences in what you're experimenting with and researching on?
Yeah, good question. No, we haven't yet. So our sample was very small. 300 movies is really small. We're raising money now to go from 300 to 3,000, which would really help us to allow really subsetting. Because if you subset from 300, then which is already a very, very small sample, then you're getting an even smaller sample, and so it's getting sort of really ridiculous from methodological standpoint. So we're collecting data on thousands of movies, and we're going to look at that. But I'm personally really interested in a very, very purely cognitive approach to it, which is across cultures, right? And so you have to. Then it's going to be really neat looking at, well, what are the patterns, what are the constant across cultures, and where does it change? We're building also a big application looking at Chinese film audiences. There isn't as much insight about Chinese film audiences in Hollywood that there should be. So we're doing that right now. Yep.
Can you elaborate a little bit more on the data collection methods that you have with the Chinese film market, since everything is mobile?
Can you repeat that? Sorry,
Can you elaborate a little bit more on some of the plans that you guys have for data collection methods for the Chinese film market, seeing as everything is kind of mobile based over there?
I'd rather not talk about it.
What other applications or industries outside of entertainment are you targeting with corporate?
All of them. We want to be the oracle of the AI age. We have proof of concepts with pharmaceutical companies, big banks, defense contractors. This is something that we've already deployed in many of our Novo Mente contracts, but it was not an enterprise product, and we're sort of turning it into an enterprise product. Now we've raised $2 million to do that. Yes?
You had a slide that mentioned sort of virality and viral stuff. Mm-hmm. Is it tougher to analyze that since there's not really a plot and it's really visual? Like, is it tough to figure out why stuff goes viral, or do you have like insights into how that works with AI?
So if we're measuring influence, it's different than virality. Virality is really tough. Influence is a little bit more stable.
Okay.
In other words, you could just literally look in the conversation for natural language markers of people that have turned into something. So this is an application that we've prototyped for the US military, looking at scoring the people that were the most influential to get other people into ISIS, and scoring the people that were the most influenceable to go into ISIS. And so there's some behavioral markers that we're detecting in the conversation.
I have two questions. First question is build upon, you mentioned like you have studied on Chinese audience for the Hollywood titles, but what about the vice versa? And then also someone mentioned cross-culture, so do you study like other language titles, like movies? We
will, but we're sort of fairly early in that effort. It's also massively expensive to do it because we have to, unfortunately, we haven't found a way to get machines to tag movies with sort of purely cognitive because it's very abstract, it's very nuanced, and as everybody knows here, machines are not very good with nuance and abstraction. So yes, doing it for Chinese cinema is obviously down the road, because again, this is such a huge market, and a lot of films that Hollywood thinks are going to do really well are doing terribly, and a lot of films that Hollywood doesn't really think are going to do well do really, really well. So, and it's a really high stakes game too, as well.
Yeah, and also second question, because you mentioned it's high cognitive like recognition scene. Your tag is based on, I saw you have some demo on the same like language design. Do you do visual, like the visual scene, or you consolidate social media? Do you do study not only comments, caption, and also pictures? Visual?
Yeah, we study everything.
Oh, okay, so
yeah.
it's kind of everything, all aspects.
Yeah, we measure everything, or everything that we can measure. Yeah.
Okay, thank you.
Yep.
With this level of data collection and analysis going into future movies, where do you see like the influence of like professional critics or like tastemakers or like things like that in the future when you have something like this driving a lot of business decisions or producing content?
Yeah, that's a really good question. So we're looking at it now at a broad level, but we really want to look at it at a more sort of granular and cognitive level down the road. This is definitely something that everybody's really, really interested in, right? What is the influence of Rotten Tomato scores on box office returns? And it's really not uniform across genres. And the other thing that we're doing is trying to measure movies a little bit smarter, like to classify movies in a smarter way than just by genre. Because really classifying by genre or even segmenting by demographics just doesn't work anymore. Right? Demographic segmentation is just failing across industries and across domain of analysis. So we think it's much better to segment people by the kind of stories that resonate with them positively or negatively. We think it's an extra dimension that probably might be the X factor in explaining why people gravitate towards certain movies and films and politicians and ideas versus others. We're really trying to break new ground in that field of looking at things more cognitively